forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. So in this video, we are going to look at the inverse tangent function. So now we've talked about sine inverse and the cos inverse too. Let's talk about tangent inverse. So when I take derivative of this, what am I going to get? So let's just go through quick. So dy over dx is equal to differentiating tangent inverse of x. So don't forget that if you're enjoying the video, don't forget to give us thumbs up and then also give us comment in the comment section. So now when I differentiate tan inverse, what we are going to get from here is we are going to get 1 divided by 1 plus x squared. Very simple. And I think this is kind of different from the sine inverse and then the cos inverse. Good. So that's basically what we are going to get from here. So now let's write this one. So when I differentiate tan inverse of x with respect to x, this should be giving us 1 divided by 1 plus x squared. Now addition is commutative, so sometimes you can see it this way. X squared plus 1 is also the same thing with this. So pay attention to that. So now let's go through the proof and see how we are going to get this here. So I think we've done for sine and cos, so you know basically what we are going to do here. So I'll take tan on both sides to have tan y equals to, then this one will just be x. Then we take the derivative with respect to x. So I need to differentiate the left side with respect to x and differentiate the right side with respect to x. So when I differentiate sine, when I differentiate tan, what am I going to get? When I differentiate tan, I get secant squared of y times this one. We are using the implicit differentiation, so we need to differentiate what is inside, and we are going to have dy over dx, or let me say we are using the change rule. So after I'm done differentiating the out function, I need to differentiate the in function, which is here. And when I differentiate x with respect to x, I get 1. So it means that my dy over dx is going to be 1 divided by secant squared of y. So now let's go for another trig identity. We know that 1 plus, so since the angle is y, I want to use y. 1 plus tan squared of y is the same as secant squared of y. Great. So we want to change this. So secant squared of y is the same as this. So now we can write this one as 1 divided by 1 plus. So don't forget, tangent squared of y is the same as tangent of y all squared. So I can write this one as tangent of y all squared. Now what can we do again? Let's go up and see what is tan. Tan y is equal to x. So now we just do substitution there, and we have 1 divided by 1 plus x squared. So this is what we are going to get at the end of the day, and you can see that it's the same as what we have here. So this is the proof for, when we differentiate tan inverse, we getting 1 over 1 plus x squared, or 1 over x squared plus 1. Now let's think of, when the function is not in terms of x and we are differentiating with respect to x, right? So for example, we want to differentiate tan inverse. Now this becomes the general rule which we can use to differentiate all tan inverse function. So now I want to differentiate tan inverse of u, and we are differentiating it with respect to x. So it means that now the function here is not with x. So it means that this is going to give us 1 divided by 1 plus x squared, u squared times u prime. So this is what we are going to get. So we just need to get u prime here. Here, when we multiply this one by x prime, because we are differentiating it with respect to x, x prime is the same as dx over dx, which is going to be 1, right? So it's just going to be multiplied by 1. So that's the reason why we don't see what is happening here like this. Great. So here we are assuming what if what is inside the parentheses, when we differentiate, we are not getting it to be 1. Then what are we going to get? So this is what we are going to get. And when we use this, we can differentiate all tan inverse function. So let us practice and then, see how we can go with this. So first we want to differentiate this function here. So d over dx, and then x squared minus 3 tangent inverse of x. Great. So what can we do here? So here we can use the product rule, right? We have two functions. So I can say that let my a be x squared minus 3 and my b equals to tan inverse of x. So what is a prime? Okay. Power rule, this is going to give us 2x, because when I differentiate the constant, it gets to 0. Use the power rule and you get this. Now, what is b prime? Okay, we just learned that tan inverse, when I differentiate with respect to x, I should have 1 divided by 1 plus x squared. Great. So when we differentiate this, what are we going to get? Because we are using the product rule says that if I use a and b, then this is going to be a b prime plus b a prime. So we just do substitution, or you can say that this times this and then this times that. So a is x squared minus 3 times b prime is 1 divided by 1 plus x squared plus b is this. So we have tan inverse of x times a prime is 2x. So when we simplify this, we can have x squared minus 3 divided by 1 plus x squared plus 2x tan inverse of x. Nice. So this is what we are going to get from here. Now, very much simple here. So it's good for us to be knowing all this. Let's do for this one too. We have y is equal to tan of x minus tan inverse of 2x. We put this one into parentheses. So what is dy over dx? Okay, this is going to be d over dx in parentheses tan x minus tan inverse of 2x. Now, when I differentiate tan, what am I going to get? So don't forget the derivatives of trig functions. So when I differentiate tan of x, I'm going to get secant squared of x. Yes, you are right. You said it right. So now let's look at how we can do this. And we are going to use the general rule that we learned here, right? This is the general rule. So let's use the general rule idea. I want to take it step by step so that you get used to it. So we know that when I'm differentiating tan inverse, and this is not just x and it's anything, then this with respect to u is 1 divided by 1 plus u squared times u prime. So from here, we can see that u is equal to 2x. So when I compare this tan inverse, what's inside the parenthesis here is 2x. So u is this. We need u prime. So what is u prime here? U prime is 2. So we just do substitution and we are done. So this is going to be minus 1 divided by 1 plus u squared. U squared by u is equal to 2x. So we are going to have 2x squared times u prime. U prime is 2. So this is going to give us 2. Nice. So this is what we are going to get. Very, very simple, right? Great. So this is going to give us secant squared of x minus 2 divided by 1 plus 4x squared. Wow. Wow. This is amazing. Let's do more practice and then we see what is going to happen. So don't forget to subscribe. If you have not done that, give us a like for us to grow in our community. Let's look at this. Differentiate this. Nice. This is nice. So we have y, which is equal to tan inverse of 5x plus 5 plus 4, and then this is 5. So what is dy over dx? Oh, nice. So this is a composite function, right? We have a function inside the parentheses with this. So first, we need to apply the power rule first. So let's apply the power rule. The power rule will let us drop this 5 here and subtract 1 from the 5. So it's just going to be 5 drop down. We maintain everything in the parentheses. We are not going to touch that. And then we subtract 1 from 5. So this is just the power rule. So 5 drops down. We maintain everything in the parentheses, and then we subtract 1 here. Then now, times, so the chain rule says that now we can differentiate what is inside the parentheses. So now times the derivative of what is inside the parentheses here, the whole of this. So now we want to differentiate tan inverse of 5x plus 4. Great. And that's why we can use the general rule for differentiating tan inverse. So d over dx of tan inverse of u was equal to 1 divided by 1 plus u squared times u prime. Compare this and this, we can see that u is equal to 5x plus 4. So u is equal to 5x plus 4, and we need u prime, which is going to give us 5. So you see that this is very simple to deal with. So let me just bring this one here so that I can now write this one to be 5 tan inverse of 5x plus 4 all to the power 4 times, so this is now going to be 1 divided by 1 plus u squared, by u is 5x plus 4 all squared times u prime is 5, which is very, very, very simple to be dealing with. Great. So now what can we do here? If you want to simplify something here, then I can multiply 5 to 1 to 5. So this is going to be 25 tan inverse of 5x plus 4 all to the power 4 divided by 1 plus 5 plus 4 all squared. So this will be the awesome answer that we are going to get here. Nice. I hope you are enjoying it. Oh, let's do this one too. We are almost done. Then I'll give you a trial question to also try. So now let's look for dy over dx. So dy over dx is going to be d over dx of tan inverse of, so let me use square bracket here, tan inverse of x minus 2 divided by x plus 2. Great. Now what can we do here? Okay, now we can make sure that we have tan inverse here. So here we have our function here, tan inverse of u, which is equal to 1 divided by 1 plus u squared times u prime. So when you compare this to this, we can see that u is equal to this. So u is equal to x minus 2, x plus 2. So what is u prime? Oh, nice. Now u prime here, we need to use the change rule. Oops, we need to use the quotient rule. Right. So u divided by v. That's what, okay, we are using u already. So let me use something like a over b. Okay. So we are going to have a divided by b. So it means that here our a will be x minus 2 and our b will be equal to x plus 2. What is a prime? A prime is 1. And what is b prime? B prime 2 is 1. So we're just differentiating constants. It will be 0. When I differentiate x, I'll get 1, 1 here. So what is the change rule? Okay. Why am I saying change rule a lot like that? Okay. Change rule, I'm not calling you. I'm calling quotient rule. Quotient rule. Okay, so using the quotient rule, we maintain what is at the denominator here. So we are going to have b, and we differentiate the top, minus, now we maintain the top and differentiate the down, all divided by the down squared. So let's just do substitution from this into this. So b is x plus 2 times a prime is 1 minus a is x minus 2 and b prime is 1, all divided by b squared, which is x plus 2 whole squared. Now we can try to simplify this. Let's do that. X plus 2 minus x plus 2. So what is happening here? Check here. When I multiply through by 1, I get the same thing. When I multiply this one by 1, I get the same thing here, but we are going to multiply 2 by minus. So minus times x is minus x, and minus times minus 2 will be positive. So this is going to be divided by x plus 2 squared. And this is going to give us x will cancel x. So we are going to have 4 divided by x plus 2 all squared. And one thing that you need to do here is, I'm just teaching. So I want to show step by step so that everyone understands what I'm doing here. But if you are very good and you are doing it, you can skip some of the steps and then you are also good to go. So now we have u prime. We have u. We can just now go by doing substitution inside what we want to solve. Okay, so let's do that. So now here is going to be 1 divided by 1 plus u squared, right? We need u squared. But this is our u, so this is going to be x minus 2 divided by x plus 2 squared times u prime. What is u prime? U prime is this, 4 divided by x plus 2 all squared. So if we want to simplify, it's good, right? We can decide to simplify this. So let me try and see if I can simplify what we have there. Okay, let me just bring this one down small and then bring this one too down small. Okay, and let's try and simplify this. So if I want to simplify this, this is the same as 1 divided by 1 plus x minus 2 squared divided by x plus 2 squared, because I know that a over b all squared is the same as a squared divided by b squared. So this is what's going to happen here, times 4 divided by x plus 2 all squared. Now let's try and work around this, and this is the same as 1 divided by x plus 2 all squared plus x minus 2 all squared divided by x plus 2 all squared. So what happened there? I know that 1 plus a over b, this is kind of like divided by 1. So I just multiply this to this, then this to this, then I now multiply this to this. So this times 1 is this, plus this is divided by 1. So 1 times this is going to give us the same thing. Then since this one is divided by 1, 1 times this is going to give us this. And times 4 over x plus 2 all squared. Now I know that 1 divided by a over b is the same as b over a. Because of this one here, we can reciprocate. So this one can be reciprocated. And we are going to have here to be x plus 2 all squared divided by x plus 2 all squared plus x minus 2 all squared times 4 divided by x plus 2 all squared. Then now we can cancel this guy and this guy. So finally, we are going to have this one to be 4 divided by x plus 2 squared minus x minus 2 squared. Great. So this is what you are going to get for this particular function. You see, it's very fun if you know how to, differentiate individual functions, right, or specific functions. So when we are solving more examples and we have complicated functions which involve tan inverse, natural log functions, we will talk about all those things, exponential functions, then you know that, okay, this is how we differentiate it, and then this is how I'll be able to approach the specific questions. So in every questions, whatever we want to, or in every question, for us to differentiate, we need, two things: how to differentiate a specific function and the rule that we are going to use. So how many rules that we have? We have the chain rule, we have the product rule, we have the sum rule, we have the quotient rule, and then let me say we have, I think the rules are 5 or so. And then we need to also learn how to differentiate specific functions. What are the specific functions? How to differentiate sine inverse, cos inverse, natural log function, exponential function. These are all functions that if you know how to differentiate, differentiation becomes pretty much more easier than any other, math topic that you are going to take in the future or you have taken it before. So yeah, I will leave a video in the description. Make sure that you check it out to know how to differentiate, different types of functions and the rules. I mean, the rules and how to differentiate a specific function. All right. So in the next video, I think we are going to talk about another, either it's the, I think it's cotangent, right? We are going to talk about the inverse cotangent of a function. So see you in the next video.